Enterprise AI creates value when it connects to real users, processes, data, and systems. In this section, we'll look at the application and integration patterns, APIs, workflows, events, and deployments that turn Azure AI capabilities into governed business solutions. We have already built 3 layers of the story. TOGAF gave us the enterprise architecture foundation, stakeholders, principles, requirements, and a case study around a secure AI platform. The ADM then moved us from vision into business, data, application, and technology architecture thinking. After that, we established the Azure Foundation, landing zones, identity, secrets, data services, and AI capabilities. Now we shift into integration and application architecture, where those pieces become real enterprise capabilities. From there, we'll move into security, governance, responsible AI, and zero trust. Enterprise AI becomes valuable when it becomes part of everyday work. A model sitting by itself is only a capability. Integration architecture exposes that capability through secure APIs, applications, workflows, and event streams so it can interact with CRM, ERP, SharePoint, ticketing systems, data platforms, and user channels. Application architecture shapes how people experience the solution, how it scales, how it is deployed, and how resilient it remains in operation. In TOGAF terms, this is where application, data, and technology architecture come together as a usable solution. This layer acts like the access point and traffic system for enterprise AI. Users may come in through web, mobile, Teams, portals, service desks, or existing business applications. API management provides the controlled gateway, applying policies, security, throttling, and versioning before requests reach workloads. Those workloads might run in app service, functions, container apps, or AKS, depending on complexity and scale. Logic apps automate processes, while Event Grid and Event Hubs move events and streams. Underneath, identity, secrets, monitoring, and governance keep the environment secure and operable. Azure API Management gives applications a governed way to reach AI capabilities. Instead of every app calling models, search, embeddings, or orchestration services directly, requests pass through one managed layer. That layer can authenticate callers, apply throttling and quotas, validate requests, transform payloads, route traffic to the right backend, and capture logs for monitoring. It also hides implementation details. A service might run on Azure Functions, App Service, Container Apps, AKS, or even an external platform. Consumers see a stable, documented API, while teams can evolve the backend safely. For AI-enabled applications, the hosting choice should follow the workload pattern. Azure Functions fits event-triggered work that runs briefly and scales automatically, such as processing uploaded documents or starting enrichment steps. App Service works well when you need a reliable managed home for web apps, REST APIs, or portals with predictable runtime behavior. Container Apps is a strong fit when the solution is containerized and needs microservices, background workers, or event-driven scaling with more deployment flexibility. The decision comes down to scaling, runtime control, packaging, and integration needs. Secure integration starts with one trusted identity plane. Users, applications, and service identities authenticate through Microsoft Entra ID, which issues tokens using standards like OAuth and OpenID Connect. The API layer should never assume trust just because a request arrived. It validates the token, checks scopes and roles, and applies least privilege before reaching backend data, AI, or key services. For Azure services, managed identities remove stored secrets from the design. Authorization then adds business context: who the caller is, what data is sensitive, and what action is appropriate. Enterprise APIs need more than a clean contract. They need guardrails. Throttling and quotas prevent one client, workflow, or agent from overwhelming backend AI services or creating runaway cost. Versioning lets teams improve an API without breaking existing applications. At runtime, resilience patterns keep user experiences stable when services fail or slow down. Use retries carefully, add timeouts, apply circuit breakers, return fallbacks, cache safe responses, and move long-running work async. For AI workloads, also plan for variable latency, rate limits, model outages, and graceful degradation. Azure Logic Apps connects AI services to everyday business systems. A workflow might start when a document lands in SharePoint, extract the text, Call an AI model to summarize or classify it, and route the result for approval. It can then create a Dynamics or Salesforce record, update SQL, open a ServiceNow case, and notify a team in Teams. The value is not heavy custom code. It is fast orchestration, broad connectors, and clear visibility into each business step, especially when exceptions need human review. Event-driven integration lets systems react to change without tightly depending on each other. Event grid is best when something happened, and you need to route that notification, such as a new blob, a resource update, or a business event. Event hubs is best when events arrive continuously at high volume, such as telemetry, logs, clickstreams, or IoT signals. Both patterns decouple producers from consumers, so AI services can scale independently. This enables real-time anomaly detection, document ingestion triggers, customer interaction analysis, and streaming feature pipelines. Think of the AI assistant as an orchestration layer, not a standalone chatbot. In a customer support workflow, it may pull customer profile and history from CRM, check policies and knowledge articles in SharePoint or Microsoft 365, and read the current incident from ServiceNow or Jira. If the issue involves orders, billing, inventory, or fulfillment, ERP data may also be needed, with stronger controls. The AI can then summarize the case, classify urgency, recommend next actions, and draft a response. The key is secure, governed access to each system of record. Deployment choice is really an operating model choice. App service is best when you need a managed web app or API with predictable hosting and minimal platform overhead. AX gives the most control for complex microservices, custom networking, and enterprise Kubernetes standards, but it also requires stronger platform engineering. Container apps sits in the middle. You run containers and event-driven services without managing the Kubernetes layer. Serverless with functions or logic apps is ideal for integrations, triggers, and bursty workflows where reducing infrastructure management is a priority. A practical way to choose is to start with the workload and the team. For a straightforward web app or API, app service keeps operations simple. If the app is already containerized and needs event-driven scale or background workers, container apps is often the lighter fit. Choose AKS when Kubernetes control, portability, networking, or platform engineering are real requirements, not just preferences. For trigger-based automation, integrations, and short workflows, functions and logic apps shine. The right choice balances business needs, architecture, skills, and operational capacity. Operational readiness is where architecture becomes dependable in the real world. For applications and integrations, 4 disciplines work together. First, observe everything: health, latency, dependency failures, user experience, and traces across services. Second, automate delivery, so APIs, workflows, infrastructure, and configuration move through repeatable CI/CD pipelines. Third, govern the environment with naming, tagging, policies, separation of test and production, security controls, and review checkpoints. Finally, measure what matters: error rates, request volume, workflow duration, token consumption, integration failures, and AI service cost. Without these practices, the solution may work, but it is not yet ready. The main takeaway is that enterprise AI becomes useful when it is wrapped in architecture, secure APIs, connected workflows, and deployment choices that fit the workload. Azure services provide the building blocks, but the design decisions create reliability, control, and operational confidence. Next, we shift from connected solutions to secure and responsible AI, focusing on risks, zero trust, and governance.